Howdy and welcome to our case study investigation. I am Maya and with me is Andrea. Today we'll be giving y'all a quick look into the results of our semester-long entomology investigation. This semester we have been investigating the pathogen Salmonella bongori and its vector Aedes vexans. We researched and planned for disease control and eradication, and here are our findings. Before jumping into the nitty-gritty of our case study, it is my pleasure to announce our hardworking and talented team. Again, my name is Maya, and I am a junior biomedical science major here at Texas A&M University. With me today is Andrea, who is also a sophomore biomedical science major from Nicaragua. Our Aggie coworkers are currently out in the field. On board, we have Jasmine, a journalism minor from Garland, Texas. We have Sarah, a neuroscience minor, hoping to go to medical school. Zach, a biomedical science major with a dream of becoming a cardiologist. Marina, a sophomore entomology major with her eyes set on veterinary school. And last but not least, Kayla, a biomedical science major applying for physician assistant school. During our case study, it was determined that our vector was the Aedes vexans. This mosquito is a medium in size and is usually brown in color. Aedes vexans usually appears narrow rings of white scales on its back, which allow us to easily identify them. This mosquito's name, vexans, translates to annoy, torment, or harass, which is very fitting of the insect as it bites in the early evening when people are outside. This particular species of mosquito is prominent in southern Canada and throughout the United States. They are one of the most prevalent mosquitoes in the U.S. and have surprisingly been found in every continent except Antarctica and South America. It has been labeled as one of the most prominent pest mosquitoes. This mosquito is a very strong flyer, which allows it to travel so far across several areas. Although our vector is present worldwide, the inland floodwater mosquito is not prominent in higher elevations, including mountains and high latitudes. The Aedes vexans is also known as the inland floodwater mosquito. The female is the predominant biter, as she feeds during and right after sunset and takes every opportunity to take a blood meal. Once they bite, they will continue to come back until they are either killed or have gotten a whole blood meal. This is the main reason why it is usually difficult to get rid of them in areas they are commonly found. Humans are not the only mammals that are bitten. The mosquito will also feed on cattle and deer when given the chance. These wide range of mammals to feed on allow the mosquito to be able to survive in the majority of our countries. The inland floodwater mosquito got its name from its mating habit. Once the female and male have mated, the eggs are placed near floodwater. The mosquito lays its eggs one at a time near damp areas or pools of water. Once they lay their eggs, they will hatch when the area is temporarily flooding with water and immerses the eggs. This may be heavily affected with large climate changes and extreme flooding that would disturb their laid eggs. For our investigation, we had 10 patients. Most of our patients reported flu-like symptoms, such as high fevers, dizziness, chills, and body aches. Some even experienced malaise, hallucinations, inconsistencies in blood sugar levels, and bloodshot eyes. All of our 10 patients passed away within days of showing the initial symptoms. As you can see, all of our patients are spread across North America, with most being inside the United States, except for one in Canada, and all had recorded contact with the outdoors, which ended up exposing them to our vector, Aedes vexans. With our patient information, we determined Grace Clements was our patient 0, due to her having the first reported case, falling ill March 17, 2017. We were informed she is from Midland, Texas, but was exposed to the pathogen in Big Bend, Texas. She had been camping out in Big Bend National Park with her 2 dogs, who are known to chase rabbits around. From February 28th to March 14th, she was out in Big Bend National Park. When she was out camping, it was very cold and rainy, and she reportedly got bitten by several mosquitoes and was exposed to ticks from her dogs. She ended up collecting 3 different species of vectors: Aedes vexans, a mosquito, and our identified vector, as well as the cat flea and Amblyomma americana, a tick. The reservoirs are Silvageus paustris, Silvageus richmani, Silvageus onsonus, Lepus townsendi, and Lepus californicus. Jackrabbits. Jackrabbits in particular have hiding places in California, Georgia, Alabama, Florida and South Carolina, New Mexico, Kansas, Wisconsin, Iowa and Illinois, Virginia, Washington, Colorado, Nevada, Canada, and several other places. The habitat for this reservoir varies with each location and each state that it is found in. Its peak time of the year, mostly in the spring, summer, or fall, depending on the specific breed. This was a solid lead to our vector because several of our patients reported having contact with rabbits. For example, patient 0, whose dogs would chase rabbits around. Our agent identified was Salmonella bongori. This disease is an enterobacteriaceae and is gram-negative. This disease agent is responsible for salmonella. The salmonella infection is fairly common. According to the CDC, salmonella infection causes over 1 million illnesses a year, over 20,000 hospitalizations, and around 450 deaths. Salmonella affects all ages, but risk of severity is often linked to age and strength of the immune system. Children under the age of 5 are more likely to get infected with salmonella than any other age group. This may be due to the lifestyle and sanitation. Symptoms and risks that are caused by this disease agent include nausea, vomiting, headache, bloody stool, diarrhea, fever, pain and cramping in the stomach, and joint pain. Salmonella infection is food, especially meat. Proteins that are often contaminated with salmonella include poultry, beef, and pork. Eggs and milk can also be contaminated with salmonella. Fruits and veggies, due to having contact with fertilizer, are also not safe from contamination and can thus carry salmonella. The control plan that was conducted by the team was a reservoir to pathogen and reservoir to vector link. The disease cycle links between the reservoir and the pathogen, Salmonella bongori, and between the reservoir and the vector, Aedes vexans. They can both be broken by orally vaccinating the jackrabbits and other rabbits. By orally vaccinating the jackrabbits and the other rabbits, this should slow the speed of the pathogen in the environment. Vaccinating the reservoirs against the pathogen also stops them from becoming infected by the pathogen in the first place, and it stops the reservoir from transmitting the pathogen to the mosquitoes. This means that less humans should get infected with the pathogen. The oral vaccine baits will be distributed once a year in the yearly to late spring near water sources and rabbit hiding places. These locations for the oral vaccine baits were chosen based on where the jackrabbits and other rabbits are typically found, and most of these rabbits are most active in the spring. The oral vaccine baits will be distributed every year until very few rabbits are found with the pathogen, and then they will be distributed again if there is another human case. After, it's thought to be eradicated.
Our control plan to intervene in the vector-to-host link is a technique that has been proven effective, especially with Aedes vexans, which has a long range of flight. It has been the sterile insect technique. Sterile males are released into the affected areas to mate with female mosquitoes. This lowers the reproductive potential of female mosquitoes. The one flaw in this technique is that it must be repeated in intervals due to changes in season and precipitation levels. The control plan we have chosen to reduce the exit from host link is not that specific to our case, since it can be used to prevent disease transfer for many different pathogens. First is the isolation of infected humans to lessen the risk of exposing other individuals to the pathogen. This includes medical professionals. You must also periodically check on the patient to monitor their progress. The second part is general waste management, making sure everything that has been in contact with the patient is properly disposed of and placed in a biohazard bag. For the last part of our control plan, we want to use human vaccination to prevent people from getting sick from this pathogen. Human vaccination has been shown to be 94% effective. Although no side effects have been reported, it is refused by 80% of the population because they question the safety of these vaccines. Even though there are studies being done on long-term effects and toxicity, without any findings that vaccines are detrimental to an individual's health, majority of public disapproves of their use.
Thank you for your time, and we hope you have learned a lot from our case study this afternoon. Throughout this year, we have conducted several investigative techniques and knowledge from our medical entomology professor to come to this conclusion as we present our findings. On behalf of me, Andrea, and our amazing team, thanks and Giga Maggies.